This is Dr. Moberly, and we're going to look at integration by parts. And this is by the tabular method. When you have to do repeated integration by parts. And this we're going to do for a Fourier series problem of likened to 11.1 with a period that goes from negative pi to positive pi. And what function would require multiple integration by parts, more so than a polynomial? I thought I'd develop the f of x equal to minus x cubed plus pi squared x for negative pi less than x less than pi, and repeats periodically before and after that. I'm not going to specify that, but it is a odd function. As you can see, f of negative x is going to be equal to a negative f of x for all x. So it just has sinusoid components. We're going to want to compute b sub n equal to the integral from minus pi to pi of 1 over pi of f of x sine n x dx. Again, the period is 2 pi, so we don't have to make any adjustment on the sinusoid. Let's move on to the next part of this step. We've got a polynomial, minus x cubed plus pi squared x times the sine of nx. And we're integrating that, and we want to set up our table. It's a minus x cubed plus pi squared x on this side and a sine nx on the other side. We're going to differentiate, and we're going to integrate as we work our way down. This is going to be a minus 3x squared plus pi squared. This is going to be a minus 6x. It's going to be a minus 6, and this is going to be a 0. Integral of sine is negative cosine nx over n. I go into negative sine nx over n squared. Integrate again. We've got a cosine nx over n cubed. Integrate again. We've got sine nx over n to the fourth. With the tabular method, we want to assign a multiplicative sign in front according to the alternating signs. And you'll recognize this is the u and this is the v. This is your u of the first one, and this is your v of the second one. By the way, this is your du, but it becomes your u tilde. This becomes your v tilde. This is your u double tilde, v double tilde, as you do the repeated integrations by parts. We have a definite integral here, so let's go ahead and set up our terms. Minus x cubed plus pi x times negative cosine nx over n from minus pi to pi. Next we have a negative of negative 3x squared plus pi squared times negative sine nx over n squared. That's minus pi to pi. Next we have a plus of negative 6x times cosine nx over n cubed. negative pi to pi. And lastly, we have a minus negative 6 times sine nx over n to the fourth. Again, from minus pi to pi. This whole thing is going to be multiplied by 1 over pi when we get done. All right, cosine of pi. Some like alternating signs right there. So let's work this one out. We've got negative pi cubed plus I'm sorry, I seem to have forgotten a squared there. There we go. Negative pi cubed plus pi cubed for the evaluation at pi. That's going to go to 0 at pi. And then the negative pi term, that's going to give us a negative pi cubed plus pi squared times negative pi. Let's see how many negatives that is. I swear that's going to give us a 0 as well. It's going to be pi to the negative, let's see, no, it's going to be positive pi cubed and negative pi cubed. That's going to give us a 0 at negative pi. Okay, that makes sense. Now what about our next terms? Well, we've got that sine n pi. Sine n pi equals 0 for all n in z. So we've got this going to 0 and going to 0 at pi and at negative pi. Likewise, this one's going to go to 0 at pi and 0 at negative pi. So we've got two terms that might give us something. Of course, they'll give us something. I think so. Let's see, negative 6x. Yeah, there we go. I'm surprised the other term disappeared. That this is going to be our negative 6 pi times cosine n pi. That's going to be negative 1 to the n over n cubed. Subtract from that a 6 times negative pi. And subtract from that a negative 6 times negative pi. Negative 1 again to the n over n cubed. And so this is just, this doubles it. So we've got minus 12 pi negative 1 to the n over n cubed. When we combine these two terms, multiply it by the 1 over pi, and we're looking at a total of negative 12, negative 1 to the n over n cubed, or we could make this negative 1 to the n plus 1 if we want to wrap the sign inside. And we've got our terms by integration by parts. Okay, stop there.